Today's notes are on pH and pOH. So what is pH? Well, pH is a scale that indicates how acidic or basic a solution is. And we discussed that a little bit in the previous notes, where a 0 is acidic, 7 is neutral, and 14 is basic. So 0 would be very acidic, 7 would be very basic, and 7 is neutral. So pH is actually a log scale that's based on the power of 10. Which means that that power of 10 is really the concentration of the H3O plus or hydronium ion, or the H plus ion or protons. Remember that the H3O plus and the H plus are basically the same thing. So if we look here, this is a larger picture of the pH scale, a little bit more detail to it. If we look at the top part here, we have the H3O plus concentration. So a 0 is really 10 to the 0. 1 on the pH scale is really a concentration of 10 to the negative 1. pH of 2 is really a concentration of 10 to the negative 2 molarity. So as you can see, what actually happens if we look at something, a pH of 4 and a pH of 6, it's not really a difference of 2, it's really a difference of 10 to the second power, which is equal to 100. So what that means is that an acid that is a pH of 4 has 100 times the H3O plus concentration that an acid that has a pH of 6 does. So really a pH of 4, it has 100 times more H3O plus or hydronium ions than an acid that has a pH of 6. So what does this P notation really mean? Well, it's a mathematical notation that means the negative log, which means that if we take the P of x, we're really taking the negative log of x. And the log scale is based upon 10, and also basically for your sake, it is a button on your calculator. So you're going to need to find the log button on your calculator. And usually when you have that log button on your calculator, you have a 10 to the x above that log button. So this is the second function of that button. So let's get a little practice, and some of these are a little bit fun. So P of cabin, well, P of anything is negative log of what that is, so that would be negative log of cabin. And the negative log of anything, means we use our P notation. So negative log of soup would be P for the negative log soup. So the negative log of soup is P soup. And one that I like that's kind of fun is taking the negative log of turpan. I'm going to have give you guys a minute or two, so pause it so that we can figure this one out. Alright, welcome back. And so if we take the negative log of turpan, that should give us P turpan. Like I said, that's one of my favorite ones. Alright, so now going back to pH and pOH. So we're going to take what we just learned about P notation and apply it to pH. So pH, because we have that P notation, is the negative log of the H plus concentration, or the negative log of the hydronium ion concentration. Because remember that the hydronium ion and the hydrogen ion are interchangeable. And pOH is going to be then, again, because we have that P notation, it's going to be the negative log of our hydroxide ion concentration. So make sure that you underline these, highlight them in your notes, because those are important equations for us to know. Okay, so now pOH is the opposite of pH. So again, it's a scale that goes from 0 to 14, but instead of a 0 being very acidic, now a 0 is very basic. and a 14 is very acidic, and 7 is still neutral. The thing we're going to talk about is how to change pH and pOH into hydrogen and hydroxide ion concentrations. So if you remember that pOH is equal to the negative log of the hydroxide ion concentration. Well, if we want to find out what our hydroxide ion concentration is, we need to isolate this part. Well, the log is a separate function. So the first thing we're going to do is divide by -1 on both sides to move the negative sign over. So that gives us negative pOH is equal to the log of the hydroxide ion concentration. And now, like I said, we need to do the opposite function of this log to get the hydroxide ion. And that's why I talked about the 10 above as a second function of the log button, because that's the opposite function. So we're going to put 10 to the on both sides. And what happens is that this log function cancels out. So 10 to the negative pOH is equal to the hydroxide ion concentration. So that gives us the equation of OH minus concentration is equal to 10 to the negative pOH. Now we can do the same idea with our hydrogen ion concentration, but we're going to save the math and save the solving out of it, and basically just substitute in the pH for the pOH, and we get that our hydronium ion concentration is equal to 10 to the negative pH. That also means that our hydrogen ion concentration is equal to 10 to the negative pH. And again, these need to be highlighted in our notes because they are important equations and they're going to help us with our homework. Okay. The last thing that we need to know is that pH plus pOH equals 14. So if I had something that on the pOH scale was a 3, on the pH scale, that means the pH will equal 11. So an example, what is the pH, pOH, and hydroxide ion concentration of a hydrochloric acid solution that is 0.0025 molar? Well, first of all, the fact that it's talking about an HCl, that means that this is an acid. And for acids, that means that the acid concentration is equal to the H plus concentration. So that means that our H plus concentration is going to equal 0.0025 molar, which then allows us to find our pH, because our pH is equal to the negative log of our hydrogen ion concentration, so 0.0025, and that is equal to 2.60. So the way sig figs work with our pHs is the number of sig figs that are in your concentration. So sig figs in the concentration are equal to the number of decimals in the pH or pOH. So because we have 2 sig figs here, means we have 2 decimal places in our pH. So now we've got our pH found. Now what's our pOH? Well, we know that pH plus pOH equals 14. So that means our pOH is going to equal 14 minus our pH, which is 2.60. And for this, because it's a 14 is the highest number it goes, we assume that that has infinite decimal places in terms of sig figs. So that gives us a pOH of 11.40. And then the last part, so we've got our pOH, is our hydroxide ion concentration. Remember that we just said that our OH minus concentration is equal to 10 to the negative pOH, which means that our hydroxide ion concentration is equal to 10 to the negative 11.40. So when we put that into our calculators, we will use the second function of our log button. And when we do that, 4.0 times 10 to the negative 12th molar. So that gives us our hydroxide ion concentration. And hopefully that it helps you guys out with your homework, and good luck with the problems.